much going to do the same thing we did in lesson 3. We'll use an area model to add fractions with unlike denominators. The only difference today will be that most of our answers are going to be improper fractions. So we'll be able to write them as a mixed number, okay? I watched my favorite math teacher on his video this morning, and we might if we have time, okay? But he is a really good teacher, although I don't care for the way he draws. It's not really art class anyway, is it? I'm recording, just so you know. Okay, but he had some terms that I really think are good. He said, let's cut this area model into 3 equal parts. So I like the way he said that. And we'll shade 2 of them. And then in the second area model, we'll cut that into 2 equal parts, but with a horizontal line. And then he actually does the same thing down here that I do. And it's probably because he's preparing his students to go to the next step where we don't use the area models, okay? Now, on the exit ticket I assigned in block 1, there were a lot of errors in the denominator. What is 3 times 2?
6.
So that's the new denominator. Please double check that when you do your work, because we're getting up in the 20s today, okay? So now, this is what he said. Now take the first area model and cut it in half. That makes sense. And I'll cut the second area model in thirds. Then he did it like this. And probably once or twice this is a good idea. So we have 4 sections out of 6 shaded, and 3 out of 6 shaded here. So that's what I write, 4/6 plus 3/6. And that's going to equal 7/6, which is an improper fraction. And this is the part I like the best. On Zern yesterday, I noticed this. I can think of this as 6/6, which is 1 whole, right? Plus how many more sixths?
1.
1/6. Now this is what he did. He took that and he said, and let's imagine taking a pair of scissors and just cut these 2 out and add them to the first area model. So you'll have 6/6 here with how many 6 left over. So your answer will be 1 and 1/6. And I really like that way of showing you. Okay? That's all you needed to know. Now, I wouldn't suggest erasing and putting this over here. I just showed you so you could see a visual of it. Okay? So if I take a look at B,
Oh yeah, do you want the homework?
you can put it in the block 2 basket.
Oh.
Thank you. All right, so I'll cut the first shape in 4ths. And the second shape in 3rds. Shade 3/4. And 2/3. When I did this earlier, I accidentally shaded 1/3. And so that gave me the wrong answer for the entire thing. So double check your numerator.
Oh, I know why he does the different colors.
Yeah, it kind of helps with the visual, doesn't it?
Did anyone else on the homework?
Well, I'm not going to take the time, guys. I only have 50 minutes to teach math, okay? So now I'm going to take the 4ths and cut them in 3rds. And take the 3rds and cut them in 4ths. And I'm probably not going to go through and circle like I did, but I could put a dot to know I've counted it. Okay, so how many?
9 or 12.
9/12, good. And
8/12.
8/12. try and keep up with me without copying mine. Just do your own. Okay, so just let me write this real quick. 9/12 plus 8/12
17/12.
equals 17/12. Please don't shout it out. And we just saw the video. We can think of this as 12/12 plus 5/12, which equals 1 and 5/12. Now we need to look at 5/12. Will 5 divide evenly into 12? No. Do they share a factor?
Yeah.
No. So it's already simplified. Okay, you got to start checking for simplifying. All right.
What are you doing, Isaac?
Okay,
Blowing my
C,
nose.
here's what I want you to do. I want you to do the problem on your own and then look up at the board to check it.
Did you put it on pause?
No. I've noticed that the odd numbers are giving us trouble when we divide our shapes. So double check when it's like 5 or 7 or even 6 actually, because we're seeing a lot of mistakes. Boys and girls, what's 2 times 5?
10.
Double check your new denominator. Make sure you write it correctly every time.
I don't reckon that any of you guys have some lead. I do.
Okay, let's not mess with lead right now. Isaac, I found 2 pencils, so just grab one of those out of the jar for right now.
Great.
Now on Zern, this problem right here will have you decide what 1 whole is. And 1 whole is 10/10 plus 1/10. So your answer is 1 and 1/10.
Did you set the recording again?
I never pushed pause. It's still recording, okay? All right, raise your hand if you are ready to start D. Okay. Okay, on this one, we had a lot of confusion. Whoops, I don't want to be on the box, do I? Pin would work better. 7 is hard. So look how I'm doing 7. Would you put your pencils down and just look up here? I start with a space right in the middle, pretty skinny one. And then I'm going to do 3 over here. So I'll need 2 lines on this side and 3 over here, so 2 lines on this side. Rather than just starting at the front and drawing 6 lines, that's a little bit easier way to do 7 and make sure it's pretty even. And then make sure you shade 5. One half seems rather simple. I also have kids who are forgetting that I'm asking you to rewrite this below the area model, and I'm trying to prepare you for what we'll do in lesson 8. So get in this good habit right now so that it will be easier when we take the area model away. Montserrat, what's my new denominator? 14. How do you know? How do you know 14's right?
Because you do.
I'm asking Montserrat. Okay, so she added 7 plus 7. I went ahead and did 7 times 2. I looked at my denominators and I did 7 times 2. Either way is right, okay? All right, so counting these 1, 2, 3, 4, 5, I've got 10 here. And how many here?
7.
7. So rewrite it. 10 fourteenths plus 7 fourteenths equals 17 fourteenths. Equals, what would 1 whole be?
14.
14 fourteenths plus how many left over?
3
3 fourteenths.
equals 1 and 3 14.
1 and 3 fourteenths.
Yes.
Does 3 divide evenly into 14?
No.
No. Do they share a factor?
No.
No. So it's simplified. Okay, let's look at the next